In this video, we're going to solve an integral calculus problem using trigonometric substitution. So the problem is the integral of dx all over the square root of 4 minus x squared. So we can see that the problem is written in this form: a squared minus u squared, or 4 minus x squared. So our a here is 2 and our u is x. So if we see a squared minus u squared, we can make a substitution. U is equal to a sine theta. So let's now substitute u. That would be x. A is 2, then sine theta. So this will serve as our first equation. Then we're going to derive this one. That would be dx is equal to 2 cosine theta d theta. So this will serve as our second equation. Then we're going to make a right triangle here. And let me just rewrite this as sine theta is equal to x all over 2. So x will be going here and 2 will be going here. Then the adjacent will be equal to 4 minus x squared, the square root of it. So from there we need to find what's the value of cosine theta. So cosine theta is equal to the adjacent, which is the square root of 4 minus x squared, all over the hypotenuse, which is 2. Then we're going to multiply both sides by 2. So we'll get 2 cosine theta is equal to the square root of 4 minus x squared. So this will serve as our third equation. So let me just rewrite our problem earlier. The integral of dx all over the square root of 4 minus x squared. So we know that dx is equal to 2 cosine theta d theta, and the square root of 4 minus x squared is equal to 2 cosine theta. So we can now cancel 2 cosine theta here, and we'll be left with the integral of d theta. So if we integrate d theta, that would be equal to theta plus c. But we need to rewrite theta in terms of c, okay? So how do we get that? So from this original equation here, sine theta is equal to x all over 2. So let me just rewrite it here. We're going to multiply both sides of the equation by arc sine. So we'll be having arc sine x all over 2 is equal to theta. So we can rewrite our final answer as arc sine x all over 2 plus c. So that's the answer for the problem. I hope you guys learned something today, and see you again next time.